You ever see a brand new solar streetlight, all shiny and modern, go completely dark after just a year? Yeah, it's a super common and honestly a really frustrating problem. Well, in this explainer, we're going to pull back the curtain and uncover the hidden reason why some of these lights fail so fast, while others just keep on shining for years and years. And the secret? It's all hidden deep inside the battery.
So let's just imagine this for a second. Your city makes a big investment, 1,000 new solar streetlights. It's a great look, right? A symbol of green progress. But then you flash forward 2 years. What's the reality on the ground? Well, for a lot of public works managers out there, the answer to this question is a pretty disappointingly small number. So what on earth is going wrong? Well, here's the thing. It's not the solar panel, and it's usually not the LED lamp. The single biggest thing that predicts whether a light is going to succeed or just fail is the battery system. It's literally the heart of the whole operation. And believe it or not, it's where a project's fate is sealed, often before a single light is even installed.
What we're really looking at here is a tale of two very different systems. Now, on the surface, they might look completely identical. They might even have similar spec sheets. But underneath it all, they are built on two completely different engineering philosophies, and that leads to some drastically different outcomes.
It really just boils down to this simple contrast. The system on the left, it's engineered for one thing and one thing only, the lowest possible upfront price. That means shortcuts. It means using lower grade cells, and predictably, it fails within a year or two. The system on the right, though, is engineered for a long service life. We're talking 5 years or even more. And it does that by using high-quality components and a much, much more robust design. Okay, so how can you spot the difference before it's too late? Well, it turns out there's one number, one little specification that acts as the single most important clue. It's a dead giveaway that tells you everything about the system's design philosophy. And that number is the battery's nominal voltage. This number right here, 3.2 volts. If you see this on a spec sheet, it is a massive red flag. It's the hallmark of a system that's been designed from the ground up to cut costs. And this isn't just some random number. It reveals an entire engineering approach that has some really serious consequences down the line.
So why is 3.2 volts such a big deal? Well, because it means the entire system is running on just a single large battery cell. Now, to power a bright streetlight, that one cell has to work incredibly hard, pushing out a massive amount of electrical current. All that current generates a ton of heat, and heat is the ultimate enemy of a battery. It just cooks the cell from the inside out, causing it to break down and fail fast. Now let's contrast that with the professional standard, 25.6 volts. This isn't just a higher number. It represents a fundamentally different, way more robust architecture. This is the kind of system that's actually designed for long-term, serious infrastructure. So how does this make for a better system? Simple. A 25.6-volt pack uses 8 high-quality cells all working together as a team. And with that higher voltage, the amount of current needed to power the exact same light is dramatically lower. Lower current means less heat, less stress on every single component, and way higher efficiency. And the result? It's simple. A much, much longer and more reliable light for the light.
But here's the thing. Using good cells is really only half the battle. You can have a system with the best grade A cells in the world, and it can still fail if the battery pack itself is just poorly put together. The manufacturing process is just as critical as the design itself. This quote right here really says it all. Battery pack quality is a system outcome. Good cells alone are not enough. You can't just throw a bunch of good parts in a box and expect a great result. True quality, the kind that lasts, comes from a disciplined process, from the very start to the very end. So this is what a real professional manufacturing process looks like. First, they actually test and match every single cell to make sure they're all going to work in perfect harmony. Then they use precision welding for the connections so they won't break from years of vibration out on the street. Next, and this is a big one, they test the battery's brain to make sure it's working perfectly. And finally, they seal the whole unit up tight to protect it from rain, dust, you name it. And that brings us to the brain of the battery. A cheap system? It often has just a simple protection board. Its only job is to stop a total catastrophe, like a fire. But a professional system uses a true battery management system, a BMS. And it's not just a guard, it's an active manager, constantly balancing the cells, monitoring the temperature, and optimizing performance to squeeze every last drop of life and health out of that battery. All right, next step, certifications. Now, I know this can feel like just a bunch of boring paperwork, but stick with me because there are two standards in particular that tell you everything you need to know about a battery's safety and, more importantly, its durability. First up is IEC 62133. The best way to think about this one is as the essential safety standard. It's all about testing for resistance to fire, explosion, and other catastrophic failures. For any product that's going to be installed in a public space, this is the absolute non-negotiable minimum. It's just table stakes. But here's the catch. Being safe doesn't mean it's built to last. And that's where IE 62620 comes in. This is a performance standard. It actually validates the battery's cycle life, its ability to hold a charge over thousands of cycles of use. This is the real proof of longevity. So here's the bottom line on that. For infrastructure that absolutely needs to be reliable for years to come, IEC 62620 is the standard you have to ask for. It's the proof that a battery is truly built to endure, not just to be safe on day one. So, let's bring this all together and take a look at the long-term payoff, shall we? The choice between these two systems, it's not just a technical one. It has a direct, massive impact on your budgets, your maintenance schedules, and, of course, public trust. I mean, this table right here just makes the trade-off crystal clear. The low-cost system gives you, maybe 1 to 2 years of unpredictable service with constant, costly maintenance headaches. The professional system gives you over 5 years of stable, predictable performance. And just look at that last row. While the initial price is lower for one, the total cost of ownership is dramatically higher. The cheap option ends up being the most expensive one by a long shot. And this right here is probably the most important takeaway of all. When a solar streetlight fails after just 18 months, it's not bad luck. It is not a random component failure. It is a predictable outcome. It's the result of a series of deliberate choices, from voltage to manufacturing shortcuts, that literally engineered it to fail right from the very beginning. Which really just leaves us with one final question for anyone involved in buying or managing public infrastructure. Is your project built to just hit a short-term budget goal, or is it built on a long-term promise of trust to the public you serve? As we've seen today, the answer to that question is hiding right there, in the battery. Thanks for tuning in.